Hi everyone, so I'm Adam. I'm the co-founder and CTO of Applitools, and today I'm going to talk about how to effectively test responsive applications on websites, which is a challenge that, at least in my experience, many teams struggle with. Now, this is going to be somewhat of an advanced session. I'm going to briefly explain what responsive websites are, and then we're going to jump directly into code. We'll implement a complete test for GitHub.com from scratch. Along the way, we'll share tips and best practices. And of course, there'll be time to answer any questions that you may have at the end. So what is a responsive website? If we look at the Wikipedia definition for responsive web design, we can see that it's an approach to web design that is aimed to provide an optimal viewing and interaction experience across a wide range of devices. But the best way to understand what that means is actually to look at a responsive website and see how it works. And we'll be looking at GitHub.com, which is a popular responsive website. OK, so here you can see the GitHub.com homepage and how it's laid out optimally for a wide screen. You can see that we have a navigation bar at the top, allowing us access to the important pages of the site. Above the fold, we have the main purpose of the site, which is to get developers to sign up. We even have room for a complete sign-up form. And below that, we have additional information that is laid out in two horizontal rows. Now, if we start to narrow the width of the browser, you can see how there is less and less room for everything. The images and the text will have room and become smaller until we get to a point where the site shifted its layout to accommodate the narrower viewport. So you can see now that the information is laid out in a single column. And at the top, we don't have room for the navigation bar anymore, so it just disappeared and was replaced with a menu button that, if we click it, allows us access to the navigation items. Now, if we continue to narrow the width of the browser, you can see that at some point, there's no room for the sign-up form, and it completely disappeared, and only the sign-up button remained. So this is an example of a responsive behavior that basically the site provides the optimal layout to whatever form factor that you throw at it. OK, so just like we saw with GitHub.com, the main factor that affects the layout of the application, of a responsive application, is the available width. And when it comes to a website or a web application, you can think of it as the width of the browser window. Or for a website, it is the width of the viewport, which you can think of as the width of the browser window minus the width of the borders. Now, the value of the viewport width is available to you in the inner width property of the window JavaScript object, and you can access that in your tests. So enough with the slides, let's start testing. As you all know, every test consists of interaction code, which basically simulates input to the application and the test, and validation code that makes sure that the output itself is as expected. At this point of the talk, we are going to focus just on interactions, and later on, we'll talk about validations. I'll be using C# to write the code. I'll be using NUnit to execute and organize the test, and Selenium to drive the web browser. Now, the reason I chose to use C# is that, first of all, it's my favorite programming language, and I'm the speaker, so I get to choose. Second, there are hardly enough examples of using C# for testing, and this is my small contribution. And third, it's very similar to Java, so I'm sure you'll all be fine following what I'm doing. OK, so let's start. What you can see here is that we have a test class called GitHub Tests, and it is marked as such with NUnit by the test fixture attribute. It has a field to hold a WebDriver, instance, and of course, a setup class that will run before each and every test. And what it does is that it creates our local Chrome driver, and a teardown method that runs at the end of each test that basically closes the browser. Now, the test or the interaction code at this point is very simple. And what it does is that it navigates to the GitHub.com homepage, which gets us here. Then it will locate the features navigation item by searching for the features in the link text, and then click it, which basically means we go to this navigation item and clicking it, which will move us to the features page. And then we'll search for the business navigation item by the link text and click it as well, which will take us to the business page. Now, before we'll run this test, what we want to do is actually control the width of the browser, because after all, we want to test the responsiveness, so we want to force it into the specific layouts that we want to test it in. And the way that I'll do it with NUnit and C# is that I want to pass it in as a parameter to the test fixture. And so I'll need a field to hold that value. I'll need a constructor that will get this value as a parameter and store it in that field. And before each test starts, I'll use that value to set the width of the browser itself, the browser window. So that would be the size property, and I pass in the width and some height. It doesn't really matter which one I use because it doesn't affect the layout, the height, so I'll use 600 pixels. And now we can run the test and see what we get. So the browser started, we get a resize, and clicking through the different pages, features, business, and we're done. So what we're going to do next is try and run it on a different form factor. Let's try a narrower viewport size and see how it works for us. Let's try 800 pixels and see what happens. So we can see the browser starting, the resize. And as you can see with the red here, the test has failed. If we look closer, we can see that we cannot find the features navigation item right here in this line. So let's look at the page and see what happened. If we narrow the browser to an 800 pixel wide viewport, you can see that actually the navigation item itself is gone, right? What we do have instead is the menu button over here that if we click it, it becomes visible, right? If we try to look at the locator for this features item, when it appears in the menu, you can see that it's still a link, and we can still locate it, but exactly the same locator. So what we can do in this case, if we want to write generic code that will actually be able to click the navigation items regardless of the layout, we can actually write a utility method that will do just that. We'll look for the presence of the menu button. If it's there, we'll just click it before we click the navigation item. If it's not there, we can immediately click the navigation item. So let's go ahead and implement that so we'll be able to do that in our test. So first, let's see how we can identify the menu button. We can see that it has a class and the class name of Octicon 3 bars. So let's use that to identify it. And now we'll write our utility method. Let's call it clickNavItem. It will take a locator for finding the navigation item that we want to click. But we'll start with finding the menu button. We'll do a find element, provide the class name that we just found, and then we'll check if it is displayed. It means that we need to click it to make the navigation items available, so let's do that. And then we can safely proceed to find the navigation button that we are looking for, and then click it. Now we can rewrite our test to use the utility method. Oops, I see I had a typo here. Let's fix it. And now let's try running the test on both viewport sizes and see what we get. Okay, so the first resize with 1,000 pixel wide viewport, moving through the navigation items, clicking them. Everything's looking good. Now the narrower viewport. And we can see that the menu is being clicked, and we are able to navigate to different pages, which is great. Now, but still, I'm sure many of you see that there is actually something very wrong with this implementation. And it's the fact that we have implementation details inside the test, right? The problem is that if we have 1,000 of these tests and then something would change on the website, we have 1,000 places to update and fix the code. What we would like to do is concentrate all those details, encapsulate them in one location, so we only have to update it. And of course, for that, we have the page objects, which I'm sure that you're all familiar with. So what we'll do now is just implement the exact same test using page objects and quickly see what we get. We'll have a base page, as usual, that will contain all the common functionality and implementation. We'll have 3 pages, a home page, a features page, and a business page to represent the pages that we are working with right now. And if we look at the base page itself, we can see that we can store there like the common implementation details, like the locators for the features and business link, and the locator for the menu button. And it will also have like common functionality, like from any of the pages, I can go to the features page, which basically means I'm calling our click nav item utility method, passing in the features locator, and then creating an instance of the features page class and returning it, and similarly going to the business page. Now that we've done that, we can also rewrite our test to be much cleaner and tidier. So we can see that after navigating to github.com, we can just create the homepage instance. From there, we can go to the features page and get it back. And from there, we can go to the business page. And now we don't have implementation details inside our test, and it's much more cleaner and readable. Awesome. So let's review some of the some tips related to the code that we just wrote, interaction code. So the first tip suggests that you should detect page layout within the page object itself. So different pages will have different layout modes, and different layout transition points. And so the proper place to encode those rules is inside the page object rather than inside your tests. This way, if those rules would change, you only have one place to update rather than updating all of your tests. If you do that, you will be able to build browser and layout independent interaction code just like we had here. I can run the same code on all the different layouts, and the same thing will happen, although it's implemented a bit differently for each page. Now, the next tip suggests that you should avoid creating layout-specific page objects. And the upside here is clear. The less page object we need to create, the less code we need to write and maintain afterwards. Now, the reason that you can do this is that just like we saw for github.com, it's also true for the majority of responsive applications, is that all the different layouts of the same page actually share the same implementation. It's the same DOM, the same elements, they have the same locators. The only thing that changes between those different layouts is the visibility of the elements, their style, and their position on the screen. Okay, so it's easy to create a single page object that can represent all the different layouts and reuse this common implementation. Now, the last tip suggests that you should avoid detecting the layout by relying on the inner width property, although it's available to you. Now, think of what we just did to figure out how to click on a navigation item. We actually looked for the presence of the menu button, and according to whether or not it's visible, we decided how to click the navigation item. A different approach would have been just to look at the value of the inner width and figure out according to it in which layout mode we are and act accordingly. Now, the downside of doing this, and the reason I recommend against it, is that it creates a very tight dependency between your page object and the application itself. So that if a developer or someone decides to change the layout transition point by 1 pixel, your test will break, right? But the way that we did it, the test is much more robust, and it would survive such changes. Okay, so now that we know how to write beautiful generic interaction code, it's time to talk about validations. But how can we actually validate responsive web design? How can we make sure that our application does provide an optimal viewing and interaction experience across a wide range of devices? And the answer is visual testing. which is exactly aimed to verify that the UI appears correctly to the end user. Now, for those of you who are not familiar with it, this is a type of testing that goes beyond the traditional functional testing that you used to do with Selenium or Appium and similar tools, where you test the functionality of the application through the UI. What visual testing is focusing on is making sure that the UI itself renders correctly, that each UI element appears in the right color, shape, position, and size, doesn't overlap or hide any other UI element. And here you can see an example from a Twitter app where, due to the narrow form factor of the device, it broke. Actually, the notification text didn't have enough room, and they overflow downwards on top of the notification below them. And this is exactly what automated visual testing tools can find easily for you, and that's why they're so suitable for what we're trying to accomplish here. Now, the workflow of an automated visual testing tool is simple. It consists of 4 steps. In the first step, you drive the application under test and take screenshots. In the second step, the tool will take those screenshots and compare them with baseline images that define the expected appearance of the application at each point of the test. And in the third step, the tool will generate a report that includes all the screenshots, the baseline images, and any differences that were found. And then you need to look at those differences if there are any and decide for each. If it is a bug, you reject the new screenshot and open the bug. If it is a valid change, you simply accept the new screenshots, so they would be used as baseline images for subsequent test runs. So what we're going to do next is we are going to add visual validation to our test, and we'll do that using the Applitools Eyes SDK. So first, we'll add the namespaces for the Eyes SDK. That would be Applitools, and because we're using Selenium, Applitools Selenium. Next, the main class of the SDK is called Eyes, and we'll add a field to hold it. At the beginning, before each test, we'll create an instance of the Eyes class. And we also point it to the Eyes server that we're working against. That would be the demo server in this case. We need to set up the API key that identifies our account. In my case, it's hidden behind an environment variable, demo API key. And what we're also going to do is set force full page screenshots to true. What we're doing here is basically telling the SDK that we want to validate complete pages, not just the parts that are visible through the browser viewport. And what the SDK will basically do is that on each validation point, it will actually scroll the application and take multiple screenshots and generate a full page screenshot for us. Now, lastly, if you recall, every time you run our test, we basically, test suite, there are several tests that's running. In this case, there are 2. We would like them all to be batched together into a single report on the Applitools Eyes dashboard, so we'll need to create a batch object to accomplish that. And we'll call the batch responsive, and we'll set it to our Eyes instance. Now we're done with the setup, and we can start actually using the Eyes class. Before we start the test, we'll call Eyes open to indicate to the server that we are starting a test. So we'll pass in the driver, a name for the application, we'll call it GitHub, and the name of the test. I'll be using NUnit to get that name. That would be inside the test context, current context, test name. And the third parameter is actually the viewport size that I want to test the website in. So I'll just take the size that we previously set as the size of the browser window and provide it over here. The difference is that the Applitools Eyes SDK will actually set the size of the window so that the size of the viewport will be that exact size, rather than the size of the window itself with the borders and everything. I will soon explain why that is very important. And of course, at the end of the test, I would like to notify the Eyes server that the test is completed, so I'll call Eyes closed. And now we are ready to add our validation code. So after we've reached the home page, all we need to do is call Eyes check window. And we can pass in a description. Let's say we'll pass the name of the home page. Now, with this, we are done. We just got 100% coverage for everything that is visible on that page. And in fact, we just saved ourselves the need to write hundreds of lines of validation code and, of course, maintaining them moving forward. Then we go to the features page, and we do exactly the same thing. We call iCheckWindow, passing in the features page as a description. And then we got that one covered as well, and we go to the business page, and we do a check window there. And by this, we've just got coverage for all those 3 pages, and you can imagine how we can continue, go through the site, and cover all the pages with just a few lines of code. Now, we are almost done with this, but there is something that's still missing. If you recall, when we are working on an hour of viewports, when we want to click the navigation item, we open the navigation menu, right? But we would also like to validate this state of the UI, because maybe the menu is corrupted. Maybe when it opens up, it ruins some other part of the page. Who knows? But here we have a small problem, because we are trying to write a generic test, responsive test, but we do need to have checkpoints that are specific to certain layout, but don't make sense in others, right? So the way that we resolve this, the proper way to resolve it, is actually to let the page object raise an event or call a callback whenever it is causing an intermediate change to the UI. Okay, so whenever it will click the menu button, which is an implicit thing that happens when we try in our test to click a navigation item, it will call that callback, and then it allows us inside our test to capture this call and add an implicit checkpoint there. So this is, I don't have the time to show you how it's implemented. We can cover that in the questions part if you like. It's very, very trivial. Basically, I can place on the constructor of the home page, I can just register a callback that says, I get a description, and what I do with it is that I call iCheckWindow with that description. And this will allow me to place that implicit checkpoint only at the points where we actually go through those intermediate UI states. So let's run the test and see what we get. Okay, so the browser is starting. We have the first resize with 1,000 pixels, and the SDK is now scrolling the page, getting those screenshots, building the full page screenshots, moving to the features page, and so on and so forth. So while the tests are running, let me explain why it was so important to set the size of the viewport rather than the size of the browser window. Now, because we are testing the responsiveness of GitHub.com, we want to test the boundary cases. We want to test the exact transition points between those layouts. And in order to do that, we have to be pixel accurate by the size of the viewport that we are setting. Now, of course, when we set the size of the browser window, we are setting a smaller size for the viewport. And figuring out exactly what the value is to put on the window so it would determine the size of the viewport is tricky. And it is also different for every device pixel ratio, for every browser type, and operating system. Because every operating system has a different border style and width, and every browser has different chrome around the viewport. So actually getting it right is not trivial, and we definitely don't have time to cover it here. But if you're interested, then all our SDKs are open source. You can just go to Applitools.com to GitHub.com and search for Applitools. And you can search for the set viewport size method in any of them. And you can see exactly like how it's implemented and also use it for your own tests. OK, so let's let it complete. OK, so our 2 tests has passed. And what we'll do now is go to the Applitools Eyes dashboard and see what we got. OK, so you can see that we have a new entry for the responsive batch. And it contains 2 tests. One is running with a viewport of 1,000 over 600. And if we enhance it, you can see that we have 3 checkpoints here. And the other one with the 800 wide viewport, you can see that it has 5 of them, because when we passed through the opening of the menu, we actually added additional ones. If we zoom into it, you can see that basically each of the checkpoints consists of 2 images, a baseline image and a current image. And these images are actually being compared. So if anything was different there, it would get highlighted and we would know about it, that something changed in the layout of the application. Now let's assume that we would have a little bit more time and that we would write a little bit, enhance the test, cover more pages, and run the tests on multiple, let's say, multiple browsers, and then on multiple operating systems, and we would cover like multiple viewports. So eventually we would get to a point where we have a lot of tests and many screenshots and baseline images. So in this case, we had a total of 19 tests. All of them failed and covering 4 different environments and viewport sizes. In total, we had 76 mismatches. Now, although it is easy to take like a bird's eye view on all of these changes and see that they all happened here at the top or at the header of the page and it's consistent, and let's assume that we know that we intentionally changed the color of the logo from black to green. Let's say that we expect this change. So it's easy to quickly approve or reject those changes, but still if we have thousands of these differences, it would be a bit overwhelming to go over them one by one. So what we could do is actually ask the tool to analyze those differences and group together the similar ones. So regardless of how many comparisons I actually had, I see that I have only 2 unique differences that I need to look at. Okay, if I look at the first group of differences and zoom in on difference, we can see that actually this is what we expected. The logo changed from black to green. So we can just approve all these occurrences of that same change, and then look at the other one and see that in this case, the developer did a mistake, okay? And actually the logo went away completely. So this is of course a bug and we can just reject it, and then we can immediately save the baselines and update them for the entire test run, okay? So with features like this, and there are plenty of them in the product, you can really scale your test to run tens of thousands or hundreds of thousands of tests each day without really increasing the amount of maintenance overhead that you have to perform in order to maintain those baselines. Okay, so let's continue with some tips related to the validation code that we wrote. We already covered setting the viewport size. The second tip suggests that you should use page object callbacks to validate layout-specific UI states, and that's exactly the trick that we did with the callback from the page object, okay? That allows us to add generic validation code while still having like layout-specific validation checkpoints. The next tip says that you should prefer full page validation over component validation. Now, there are 2 reasons for that. First of all, the obvious one, you get more coverage if you test the entire page versus testing like small parts of it. But the second advantage is that it actually requires less effort to create the test and maintain them. If you're doing component-specific validation, you have to keep locators for each of these components. You have to have multiple assertions for each of them. And of course, when your application will change, it's likely that those locators will break as well, and you need to go into the code and fix that. On the other hand, if you have a full page validation with a single line of code without any locator, it's easier to write and no need to change the code when the application changes. The last tip suggests that you should focus your test on the lower layout boundaries. So, of course, if you want to test the layout, the responsiveness of your app, you're not going to have 1,000 tests covering each and every possible pixel value for the browser width. You'll need to like choose a few representative values to test against. Now, as usual, there is, whenever you need to test against a range of values and you cannot test all of them, a very popular technique is to go for the boundary cases, boundary values, the upper and lower boundary, for the obvious reasons that usually you'll have this condition in the code of the system that you're testing, and it's likely that you find bugs there. Now, if you, for some reason, cannot test the lower and upper boundary of a layout mode, and you have to choose just one, always go for the lower one. Okay? The reason is that the lower bound or the most narrower mode of a certain layout mode is the most crowded and ugliest and dense form of that layout. And because of that, it's likely that you will find bugs there. Now, it's just to show you that it's not a theoretical recommendation. It's very easy to find examples that would prove it. So if we look at the Atlassian website, you can see that we have a certain layout mode. And if you look at the navigation bar, everything looks right. If we narrow it slightly to get to the just above the transition point to the next layout level, let's see it. Over here, you can see that there is a bug, okay, a layout bug here. But if we continue to narrow it by just like one more pixel, we move to the upper bound of the next layout level, okay? So it's very, I mean, most sites have bugs like this around the lower boundary cases. And basically, with this, I conclude the talk, and I'll be happy to take your questions at this point.
Very intrigued by your product. Haven't had a chance to use it. Looking forward to it. Forceful page screenshot, does that up the validation count?
No, it's just counted as one. Thanks. Okay.
Yeah, I understand that the comparison can be seen visually there, right? So can it be done in automation? Like, let's say I will go through one step, and there the comparison results also can be seen in the automation results, either in Selenium or Applitools somewhere?
Are you asking if you can integrate it with your automation so you'll see the results in the code back in the SDK?
No, I want to see in the result. Let's say like I have 2 steps in the test case. Mm-hmm. In the second step, I have some UI elements to validate, right? Mm-hmm. If there are any changes between the base and the target images, I should know that in the result itself. I don't want to go to the some place and...
Yes, you have the indication when the test, that actually an exception will be thrown by the SDK. The eyes closed method will throw an exception that will fail your test, and with a link to the result page. Or you can get a return value that shows you everything, all the information with the links and the details, what failed, how it failed, etc.
Okay, thank you.
Yeah, you're welcome.
So how to handle scenarios where, like in visual testing, if there is a element that continuously changes and that is expected to change, like there's a graph or anything?
Yeah, so it's a very good question. So first of all, there are various methods to do comparison within the tool. So one of them is to do a strict comparison, which basically emulates the human vision. It will find any difference, even if it's minute, as long as a human being can see it. So rendering differences and things that maybe the reason that Sikuli has a better reputation because of like minor pixel changes and no one can see, that won't be captured. But real differences will be captured. Now, but you can also use layout matching, for instance. If you have a table with dynamic values or dynamic text, then you can still use layout matching to make sure that the overall structure is the same. You can also use ignore regions if it's completely dynamic and unpredicted, like an ad that shows up or a date that can be different every time you see it. You can simply ignore it. And you can also mix and match those things. So I can validate the page in strict mode and just a certain area in layout because there's a table there, etc. Now, there are more complex scenarios like video that you need to validate it's running, or maybe some animation. So here, you need to put in a little bit more effort. Either you are able to work with the devs to make it more testable in the sense that if it's some animation, you can make sure it stops at certain phases so you can validate them. Okay, so let's say that you're working with Selenium. Selenium is not fast enough to like capture every frame of the movement. I mean, check window, I mean, getting a screenshot takes time. It could take like 2 seconds or 1 second. You cannot hit all the steps. But for example, users of the tool that validate video would usually use a test video, let's say with numbers counting from 1 to 100. Like every 2 seconds, they would change a frame, and then there's enough time to capture the screenshots in between. And so you can make sure that the video is not stuck and that it is progressing in the right speed. Otherwise, it will get out of sync. And so you can make sure that the server is providing a video and that the player is playing a video, right? But it's not necessarily the video that you end up showing in production. Yeah.
Do you provide SDK for Protractor?
Yes. We have dozens of them for all the major.
Also, do you have additional materials for like proof of concept or demo for like advanced data table? If this is recommended tool?
Yeah, there's a lot of material on the web, and also if you want, there's the Applitools booth there. You can go there. They will help you.
And the third question is, since you're from Israel,
yes.
Do you actually recommend using this tool for right-to-left testing?
It's good for anything that is visual. So there are plenty of use cases, I mean, from visual regression testing to accessibility testing, localization testing. Definitely, people use it to validate their sites in production, validate PDF forms, and we even have customers that use it for security purposes to make sure that customers don't hack into their sites and deface it. So everything that you can see, and as a tester, you can look at and see if it looks, and get to do your job by looking at the screen only, we can validate it automatically.
Hey, how you doing? Great presentation, by the way. I just had a question. If you have some functionality or UI that changes depending on the browser that you're using, is there any way that you can change the base image that you do the comparison on?
Yeah. So first of all, by default, the tool itself identifies the environment in which you're running the test. So running the same test with the same code on different environments, the tool will automatically create a baseline for each and will know which screenshot to compare with which screenshots. But you can also force it to take screenshots from one environment and compare with another. So you can do cross-browser and cross-device testing that way. Let's say that you have a baseline on Galaxy S4 and you want to test Galaxy S5 with it. Okay, so definitely.
As a user, are we able to set, I'm over here. As a user, are we able to set color difference threshold?
Our technology is based on is guided by the fact that we don't want people to start playing with threshold because they don't know what they're doing and eventually they like ignore everything. So we avoid this. But we do have a match level that ignores color and style differences. Okay, so it would be strict, it would find a typo, but if the text is in a different color or an image is in a different color or there's some nice shade around the letters, it will ignore it. I hope it answers the question. I'm ready to end whenever it's good.
Let's say you have a pie chart, and you want to make sure that 5 colors are in the pie chart, and it's a circle, but that's about it. Can we achieve that kind of validation?
You'll have to work a bit hard to get to it, but what I would recommend doing in that case is just make sure you use fixed data. So just make sure that that specific test that validates that pie chart uses the same data, and then you can use like strict and make sure that not just the colors are okay, that it is a circle and it does interpret the values that it's supposed to show exactly in the same way. That would be the better approach.
Okay.
Thank you very much.
Thank you, Adam.